Good morning, one and all honors physics students, for another episode of Honors Physics. This is Mr. Finn coming at you for the Wednesday edition of Physics, March 25th, 2020. I hope you guys are all well today. Hey guys, we just got a short lesson here today. We're going to talk a little bit more about amplitude, specifically how to measure that and ways that we can look at that. But first, one quick announcement. We're coming up on our last week here, our last few days before our actual scheduled spring break. So what we're going to do is we're going to do a Google form maybe by Friday. Try to make it available a little earlier in the morning, maybe about 10 a.m. Or a little later in the morning, rather, about 10 a.m. So you guys can fill out the Google form. And I'm going to use that as a summary, kind of a summary of the topics we've had over the last 2 weeks. If you want to call it a quiz, you can call it a quiz. I'm just going to use it as a summary evaluation of some kind. And I'll put it on the Google Classroom. So it's not going to go into MyStar yet. We're going to wait and see what happens with the rest of the semester. Okay, so let's talk about this amplitude deal. How do we measure amplitude in different types of waves? Well, remember, the amplitude is the size of the wave. So if this was a transverse wave, and you were moving around like this, like the Tacoma Narrows Bridge, the amplitude would be how far the antinote is from that baseline value. Okay, so if it's a sound wave, we could be talking about this in terms of decibels. A decibel scale measures the intensity or the loudness of the sounds. Now, it's not exactly a linear scale, so that does make it a little bit different. But you guys with your math background, you should be able to grasp onto this pretty well, because I'm sure you're much better with logarithms than I am. So, the first thing we got to understand is there's a baseline threshold of hearing for humans, called the threshold of hearing. And we're going to call that I sub 0, or the intensity at 0 value. So the threshold of hearing for us might be the very small sound that we can hear. Any other intensity might be called I, the intensity of the sound wave that we're trying to measure. Well, the relationship of the intensity of the sound wave we're trying to measure divided by the threshold of intensity, that becomes a logarithmic scale. And when we take the log of those two values, or the quotient of those two values, then we're going to get the actual decibel reading on the scale. It's kind of like a Richter scale for earthquakes. Let me show you what I mean. Okay guys, we're back at the magic board here. Let's take a look at this idea of decibels in terms of logarithms to make a scale that we can use. So my decibel value, sometimes called beta, is going to be in the scale that's a relationship of the logarithmic value, the logarithm of I over I sub 0. Remember, I sub 0 is the threshold of hearing, and I will be the intensity of any sound we're trying to measure. Now, there's a 10 out front, so it's a base 10 value. So another way of looking at this is this. If you had a 20 decibel difference between the threshold of hearing and some other value, like the shuffling of paper, for example, a 20 decibel difference, if I want to find how much intensity that is, I could actually take the 20 divided by the 10, I'd have 20 over here, divided by this 10, and then take the log of that. So if you take 20 and divide by 10, that's 2. So 2 becomes the exponent of the 10, because that's what a logarithm is. It's an exponent in base 10. So 10 raised to the second power is 100 times as intense. A 30 decibel difference, if you divide 30 by 10, moving the 10 over, you'll get 3. So 3 becomes the exponent in base 10. So a 30 decibel difference is 10 to the third power, or 1,000 times as intense. Once again, you guys working with decibels all the time in math class, so I'm sure you're going to be pretty decent at this. The last part is, what if I had something that wasn't in base 10? Well, still base 10, but what if it's a little odd, like what is a 35 decibel difference? What would that be in terms of intensity? Well, we know a 10 to the second power, or a 20 decibel difference, would be 100 times as intense. And And we know a 30 decibel difference will be 1,000 times as intense. So if it's 35 decibels, it's got to be more than 1,000 times as intense. What would a 40 decibel increase give you? Divide through by 10, take that 4, make it the exponent of 10, you'd get 10,000 times as intense. So a 35 decibel difference has to be somewhere between 1,000 and 10,000. But it wouldn't be right in the middle because the scale's not linear. Let's work it out and see what we... Okay guys, we're back. Did you have a little think about that? Let's see if we can work it out together. Here's my 35 decibels, and that's going to equal 10 log I over I sub O. So when I divide both sides by 10 to just get log by itself, I'm going to get 3.5 as logarithm. So you guys know how to take that logarithm and inverse. If we know that 3.5 is the exponent in base 10, then we know that 10 raised to the 3.5 power is the value of the intensity that we're going to have. So if you plug 10.10 to the raised to the 3.5 power into your calculator, you should get around 316 times as intense as the threshold of hearing. Well, that's it, guys. It's not too difficult. Let's wrap up here before we get out of here today. Okay, guys, I hope that was pretty straightforward. Remember, amplitude of certain waves is a measurement from your nodal or your baseline point to your antinode. So you guys with your elastic constant activity, you did that really well. But other different amplitudes and different types of waves can be expressed differently. For example, the Richter scale for earthquakes, the decibel scale for sound, luminosity for light. That's a little bit challenging. We'll get to that in a few weeks. But for now, maybe we just rely on the fact that we can measure sound very easily. We can measure it with a decibel scale to determine the intensity ratio. Go ahead and practice those on your own, guys, and we'll get back together tomorrow for a look back at Doppler and a few other things before we have a wrap-up on Friday with a Google form. I hope you guys are doing really well. Remember to send those questions through email if you have them, and we'll get back together on Thursday.